Hello and welcome to this instructional video on the BondMaster 600. This video will illustrate how to use the BondMaster 600 to assist with developing procedures for inspecting honeycomb composites. A pitch catch swept method is used to generate a comparative frequency spectrum. This advanced mode offers a scientific approach to frequency finding that saves time and provides a better understanding of the application. Start by properly identifying the flaw location. Not doing so may result in confusion and possible errors. Focus on near-side defects. Finding the proper frequency for near-side disbounds will often result in the detection of far-side disbounds. When possible, use a backing foam to reduce the effect of partial contact with the working table. Plan to take notes frequently, as it is easy to forget key information observed during testing. The BondMaster 600 needs some initial adjustment in order to access the advanced frequency finding mode. With your pitch catch probe connected, turn the instrument on and follow these steps. Press the Advanced Setup key, followed by Application Selection. Select Skin to Core Disbounds Tapered with a knob and press Accept. This activates the pitch catch swept method. Adjust the swept rate to low. This is important to help ensure the accuracy of results. Press the Run key twice to show the spectrum display. Press the Main key to display the special page where the frequency markers are found. Because the steps just described need to be done each time this mode is used, you may want to save the configuration and name it so it can be recalled later. The pitch catch swept method can evaluate near and far side disbound defects in an all-aluminum honeycomb sandwich. The goal is to find the frequency or frequencies that enable detection of the near side disbound. If multiple frequencies are found, they are compared to evaluate which frequency or frequency range is the most practical to use under the inspection conditions. Once all the preparation steps are complete, put the probe on a defect-free area of the sample and adjust the gain so that the amplitude spectrum reaches 2 to 3 divisions high. Hold the probe in place and generate a reference spectrum by holding the Save key. Wait for the beep. Move the probe over the defect. In this example, the signal is too large to be used, so the previous gain and reference steps need to be done again. Press and hold the Save key to remove the reference spectrum. Adjust the gain to a lower level while holding the probe on a good area of the sample. Try to keep the signal within one vertical division and set the reference spectrum again. Move the probe tips over the defect again and firmly hold the probe there. The BondMaster 600 features 2 frequency markers that are available with the spectrum display. These frequency markers can be used to identify one of the following: a single peak, the limits of a frequency range, a frequency range to avoid, or material configuration comparison. Adjust the first frequency marker to where the spectrum signal of the defect starts to deviate from the reference spectrum. Adjust the second marker to where the ratio between the defect and the reference spectrum starts to decrease. When possible, focus on areas where the reference spectrum exhibits the lowest noise. Choosing frequencies that strongly differentiate from the reference spectrum will result in a high signal-to-noise ratio when employing the pitch catch RF method. In this example, The range of 14 kHz to 22 kHz represents the highest difference in amplitude. If strong peaks are present, locate them with the frequency markers. It's useful to compare all potential good frequencies later on to choose the most practical one. In this example, a frequency of 26 kHz generates a strong peak, but not the best ratio to the reference spectrum. Locate any other interesting frequencies that exhibit a large ratio between the defect and the reference spectrums. Here, a frequency of 34 kHz is worth investigating. Note that frequencies higher than 22 kHz generate a lot of transmission, even from good material. This is important because lower frequencies are often recommended. Lower frequencies represent lower vibration harmonics and therefore a stronger amplitude vibration. Lower frequencies will usually produce a more stable test. In this example, we have identified the lowest potential usable frequency range of 14 kHz to 22 kHz. We will also try 26 kHz and 34 kHz as a comparison. To verify that these frequencies actually enable an effective test, perform a simple test with the pitch catch RF method. For more information on how to set up pitch catch RF, please refer to the Olympus online video How to Configure Pitch Catch Probes for Disband Detection. Using the pitch catch RF method, try discrete frequencies according to your notes. Since the potential frequency range is quite wide here, try to compare at each 2 kHz increment. Use the reference signal as needed in order to compare frequencies. Always set the gain first when changing frequencies. Scan the near and far side defects to see how useful each frequency is. Compare frequencies 2 by 2 and choose the one that provides the best results. You can evaluate each of the frequencies based on different criteria: signal-to-noise ratio of defect signals, detectability of far-side disband, overall stability of signals, and ease of reproducing results. Once the proper test frequency has been found, it's possible to take advantage of the flying dot gain and position controls to optimize the display. In many cases, it is possible to send near-side defects in one direction and far-side defects in another direction. The BondMaster 600 can also be used to find the best frequencies for an application involving multiple variables. For example, it's common to deal with multiple ply thicknesses, overall thickness change, or various defect sizes and locations. To find the best frequency or frequencies, simply repeat the steps discussed earlier. Treat each part and defect combination separately, as if the sample only had this one defect. For each combination, note the best frequencies. Once all frequency combinations have been analyzed, look for a common frequency. In many cases, there will be one particular frequency or a narrow range of frequencies that will stand out as applicable to all of the configurations. Put that frequency to the test using the pitch catch RF method to help ensure you get proper detection of all flaws repeatedly and with minimal configuration of the BondMaster 600. We hope you enjoyed this video on how to find the correct frequencies for inspection of honeycomb composites. Remember the following important points: know the defect location, use a higher amplitude ratio, find lower frequencies, and take notes. For more information about Olympus bond testing solutions, contact your local representative or visit us online at www.olympus-ims.com.